Okay, so in this video we're going to look at an application which we're going to have to use quadratics to solve. So if you look at the problem, we have a child at this new swimming pool at the YMCA, jumps off a 20-foot platform into the pool. The child's height in feet above the water is modeled by h of t, so the h of t represents height as a function of time. So height is a function of time. So the height is determined based on how long the child is in the air after they've jumped off of this platform. And we have an equation that's being modeled or models this situation. So we have negative 16t squared plus 20. And we'll see here this negative in front tells us that this thing opens down. So I'm going to draw a quick picture. We know it's a parabola. And so if you think about the application, we have some kid that's on a platform. The platform is right here. And they're jumping off, and they fall into the water. Okay? Water should be blue, not red, of course. Okay? And what we want to do is we want to determine how long it takes the child to reach the water. Well, we need to understand a couple things. Time is the independent variable. So time is going to be our x-axis, and height is our y-axis. And so if we look at a couple pieces, one important piece is this guy right here. That is our y-intercept. So knowing that that's our y-intercept, we know that the initial height of the individual or this child is at 20 feet. We want to know how long it takes for them to hit the ground. Well, time doesn't start until they jump. So at this point, at the origin, time is 0. Well, at this point, what we want to do is we want to understand that the height is actually 0. And that actually helps us set this problem up. And so what we need to think about is at that specific point, h, based on whatever the time is going to equal 0 feet. So we're going to set up our equation, and we're going to set it equal to 0. So I have negative 16t plus 20 is equal to 0. I'm going to solve. So I'm going to subtract 20, put it on the other side, divide both guys by negative 16, and then I have t squared is equal to 20 over 16. And I'm going to go ahead and I have a square. So I'm going to go ahead and take the square root of both of these guys, which is going to equal plus or minus the square root of 20 over 4, because the square root of 16 is 4. I'm going to take out my calculator. We want to know what time. If there's no application, we want exact answers. We would just reduce this. But I'm going to go ahead and I'm going to calculate this. So if I take the square root of 20 and divide it by 4, I'm going to get t is equal to plus or minus 1.12, rounding to the nearest 100 seconds. We have an application. We can't have negative time. So I ignore the negative, and I then recognize that at this point right here, time is going to equal 1.12. Well, if they started at 0 and this intercept is 1.12, working with the application, it took 1.12 seconds for the child to reach the water after they've jumped off the platform. So they were in the air for 1.12 seconds.